Okay, as with any factoring problem, we always start by looking for the greatest common factor. And in this case, they have a factor of 4. So we divide each of these by 4. So that gives you 2PC. And I'm going to leave space there on purpose. Minus 2PD. And then minus 12QC plus 12QD. Sorry, I forgot to divide by 4. Should be 3QC plus 3QD. Okay, and I left the space there because now we're going to put these in 2 groups. Notice the minus sign goes in the parentheses with it. So I need to put a plus sign out here to separate them. Okay, now look at each of these 2 groups and see what your common factor is. In this first group, they have a 2p in common. So we'll divide each of those by 2p. And the second group has a 3q in common. So we'll take out a 3q and divide each of them by 3q. Okay, now, and notice our 4 is still there. And it just stays there. We're not going to do anything else with it. It just kind of becomes a constant in our answer. Okay, when we simplify this first group, we get C minus D. When you simplify the second group, you get negative C plus D. And put this other parentheses here too. Now we want these 2 binomials right here to be the same. And they almost are, except the signs are different. Well, we can fix that. If we change this to a minus, that allows us to change both of these. Now you can see they are exactly the same. So now we're ready to write our answer. We keep the 4. This right here would be your first binomial, C minus D. Then if you divide these by C minus D, that takes the C minus D's out, and you are left with 2P minus 3Q. So that's your second binomial. And you can FOIL these to check them as well. Okay, again, we start by looking for a common factor, but in this case, they do not all have a common factor. Okay, now you can put them in groups. And then in the first group, they have a common factor of 2x. So we can divide them both by 2x. And then the second group has a common factor of 3. So over here, that gives us 6x squared plus 5. And over here, that gives us 5 plus 6x squared. Now remember, we're wanting these to be the same. And in actuality, they are. Because it's addition, the order doesn't matter. So even though they may not look exactly the same, they are the same. squared plus 5 would be your first binomial. Okay, again, start by looking for common factor, and in this case they all have a 2. So we can divide everything by 2. So that gives us 2 PU minus QV minus PV plus QU. Now, if we go to group, notice PU and QV don't have anything in common, neither do PV and QU. So, what we want to do is change the order around before we group it. And remember, you can change the order of addition. Just make sure if it has a negative sign, the negative sign moves with it. So instead of doing that, let's put, and there's more than one way to do it at this point, but I'm going to put the ones with the P's together. So PU minus PV will be 1, and the other one, and then that leaves us minus QV and plus QU. Now in this first group, we have a common factor of P. And in the second group, we have a common factor of Q. And let's close that parentheses there. So that'll give you P and then U minus V plus Q negative V plus U. Okay, and as the problem we had earlier, these look a little different, but they're actually the same. U minus V, notice in both of them the V is negative. So U minus V is the same thing as negative V plus U. And you can write it whichever way you like in your final answer. I'm going to put U minus V and then P plus Q.